Welcome to the FreMarq Innovations Energy Cost Savings Tool tutorial. This short video is intended to help you understand how to use this tool to estimate the impact of two different glazing systems simply by comparing their assembled U-factors. Before we get started, I'd like to make a few comments about the scope of this tool and the basis for its calculations. First, the purpose of this calculator is simply to account for thermal energy transfer without considering things like solar heat gain, building orientation, or mechanical sizing. Using a basic set of inputs, the annual energy consumption is tabulated and converted into costs and greenhouse gas production. This is in no way intended to replace energy modeling. Second, we're making the assumption that the energy source for the cooling system is electricity and the source for the heating system is natural gas. Third, the data used for the regional energy costs comes from the U.S. Energy Information Administration's website. These costs used are the average retail prices of energy for commercial use by state. The EIA website is hyperlinked to the left of the costs listed. Fourth, all calculations are based on the region's annual heating degree days and cooling degree days as defined and reported by ASHRAE. Now let's dig into the use of the tool. We'll start by looking at the boxes outlined in red at the top left corner of the page. These 8 cells are the only inputs you need in order to use this tool. For example, we'll compare FreMarq's zero-net pressure wall system, which has an NFRC system U-factor of 0.28 when paired with an IGU that has a center of glass U-factor of 0.24. For comparison, we'll use a general non-thermally broken system that has a system U-factor of 0.40 when paired with the same glass. Next, we need to choose where this particular building will be located. There are over 100 different cities to choose from, so while your exact location may not be listed, choose the nearest available. In this case, we've chosen the cold weather climate of Minneapolis, Minnesota. Once the location is chosen, we'll move down to the furnace and air conditioning efficiencies. We have 80% and 85% entered as defaults, but feel free to adjust these as you see fit. Lastly, enter the rough area of the window systems. We're using 50,000 square feet for this example. After the required information is entered, the remaining cells will populate with information. Let's start by taking a look at the system comparison section. The values provided here show a direct comparison between the two systems being evaluated on an annual basis. The cells under the red heading show the energy consumption and greenhouse gas production due to heating, and the cells under the blue heading show the energy consumption and greenhouse gas production due to cooling. The cells under the gray heading at the right sum the heating and cooling energy consumption and greenhouse gas production and converts the energy use to a dollar value. Looking at the projected savings section below, we get a breakdown of how much energy, greenhouse gas, and money can be saved on a 20-year schedule. The first year line is simply the difference between the two systems in the system comparison section, with every year laid out after that up to 20 years. This table can be helpful for determining what kind of return on investment can be realized when choosing a higher performance glazed wall system. If all the details in the two lower tables seem a little overwhelming, you can utilize the quick look table at the top right of the page to see what the year 1 and year 8 cost and greenhouse gas savings are. Once again, this tool is not intended to replace building modeling, but rather to provide a simple comparison of the performance of two glazed wall systems. With that in mind, thank you for taking the time to watch this tutorial.